Okay. Hello. Yes, I would like to welcome you here at KUHNE in St. Augustin, next to Cologne. We are here in our R&D department. My name is Rainer Boboff and I'm the business unit manager for flat film and sheet lines. Today I would like to introduce you our PET line for film. And if it comes to the processing of PET, our customers asking directly what amount of PCR material I can get into that process. PCR, post-consumer recycling material. We're talking with PET for sure of bottle flakes. Our process here is capable of getting 100% of bottle flakes into that process. But normally customers do have also in-house flakes coming from the thermoforming skeleton. So normal mixture would be 40%, 50% in-house flakes, 40% bottle flakes and 20% virgin material. Today we're going to run 80% of bottle flakes and 20% of virgin material. So next question is the amount of moisture content the material do have. So PET likes humidity, and with it, it takes the moisture in the material. And having that moisture in the extrusion process, it's going to destroy the chain length and is going to lower the intrinsic viscosity and with it the properties. So we think the earlier we can get rid of the moisture, the better it is. As you may know us for a longer time, we have implemented mostly all processes which are possible on the market, like twin screw, co-rotating twin screw extruder process with light stitch together, MAS conical twin screw, and also with EREMA we have done several lines. And the last show, 2019, we have shown here in our lab with NGR together a line having a LSP process in, means liquid state process to lift to intrinsic viscosity again. So, but here we want to have the moisture out, the moisture away, and we're going to show today infrared drum heating system with single screw extruder, our single screw extruders. And you will maybe say, okay, but the infrared drum heating system is nothing new. But in between, Kreinborg developed a system where you can directly get approval of the FDA, as the Food and Drug Administration of the US. And with them adding some extra parts, you are allowed or you are able to go in front of the EFSA, the European Food and Safety Administration, and also apply for the approval of these administration to run here film and also produce containers which are then in direct food contact. Kreinborg named that system Clean. So you might don't know the drum heating system yet. I give a short information about. So we're going to mix the 80% of bottle flakes and 20% of virgin material with a Doteco batch blending system, and then we're going to suck it into the entrance of that drum. The drum inside has a helix, and the helix is transporting the material alongside the infrared lamps. The infrared lamps are getting the energy with their wavelength into the material and going to press out the humidity or the moisture from inside to outside. But it is the opposite with dehumidified air drying, which takes 6 hours. Here we're talking about only 15 minutes to 30 minutes, depending on the moisture content. Like I said already, 10,000 parts per million. We're going to drop it to 300 parts per million. And one thing also very important is, while the material is going to tumble around in the helix, we're going to change the structure from amorphous. The bottle flakes have amorphous structure. We go back to crystalline structure, which is important for the single screw extruder process. From the infrared drum heating, we go to the finisher. The finisher is actually a buffer hopper, very good isolated. We take that material there, store it for a short while. And if it comes to these systems now, it's always then the question about energy consumption. Nowadays, the big question. This process here is integrated. That means we already lift the temperature of the flakes and the granule up to 160 degrees. And with the 160 degrees, we go to our single screw extruder. And on the single screw extruder, we have only to implement then the extra energy to melt in the material, and that's it. So in total, the energy consumption is equal to other processes. We have a customer in the Netherlands. He has all the processes possible, and he compared these, and he found not any significant difference between twin screw extruder with huge venting things and these processes here. Here's our extruder K2022, having a water-cooled motor on as the drive. The K2022 means 125 millimeter screw diameter times 33D in length. We're going to enter the material in the barrel here. It's a smooth bore. And then from there on, we're going to get the material molten. And here we have the venting ports. Actually, this is not anymore needed if you go for the finisher reducing the moisture from 300 to 50 parts per million, which is then the ability to get the EFSA approval. Here we use the venting to get the last moisture out of that process. And you see here the co-extruder. We have also a second extruder to run an ABA layer structure. This is a 60 millimeter extruder times 33D, also with double venting. And here we don't dry the material first. We go directly with the virgin material to that extruder and take the moisture out at the venting ports. The main extruder is capable of 800 kilos of that mixture, 80% bottle flakes, 20% virgin. And the co-extruder is giving us an extra of 200 kilos. So we're talking about 1,000 kilos in total of capacity of that line here. Also to say, by skipping the infrared heating system, we can also get PP and polystyrene on that machine. That means it's a multi-purpose machine. If you don't have the contracts to produce all the time PET, you can use also that line for PP and polystyrene, for example. With the bottle flakes, we also have a lot of dirt, so we need a very special screen changer to take the dirt out. We're using here a 4-cavity screen changer. Means we have much more surface to clean the material, and we do have here some hydraulic pistons to take a certain amount of material and press it from the backside to the screen. That's so-called backflush. That means we're reducing cost of screens. Using always new screens, you can clean them, so that's going to reduce costs. If you go alongside here, we come to the melt pump. The melt pump is the part from where on we're going constantly to the die. That means the melt pump is going to meter us the melt very precisely into the die. Whereas the process before means the pistons of the screen changer, for example, by getting in and out, as also the backflush taking certain amount of material away, we have irritating the process, as also the bulk density might vary from 400 to 250 grams per liter. The single screw extruder does not like it, but with the pressure gauge in front and a closed loop, we're going to rise or lower the screw speed accordingly the pressure. So the process is constantly, from here on, the extruder is taken care by the PLC, and that's it. We come here then to the melt pipe. Getting up, we have a vertical arranged die, and in the melt pipe we have a static mixer. The static mixer is a Canix type, means it's also a helix, 4 times changed by 90 degrees. We like that static mixer more if you use the X-type. X-type has the disadvantage, we see it in that way, to have dead corner areas, and that gives you over the time also degradation of the material, and that gives black spots. We're coming here to the feed block. The feed block is possible to arrange by bolts to have an AB or BA structure or an ABA structure. So you only have to place maybe an anti-block batch into your A extruder. And underneath the feed block we have a die. The die has an internal deckling. That's also needed in the PET process, because if we have external deckling, then behind the deckling we have again dead corner areas, and that gives you degradation, and with it, like I said already, with the static mixer you will get black spots. Now I want to emphasize that the feed block and the die is designed at KUHNE, and the manufacturing is done by K2022, our daughter company just around the corner. And if you see at our booth, you go to the right side of the booth, you see an 8.5 meter die for geomembrane application. That die is designed here and manufactured at K2022. But they don't only do this parts, they also do the mandrels for KUHNE Anlagenbau, our daughter company, also with us here. And you go to the left side of the booth, you see the huge mandrel, and they do these die heads up to 15 layers. And they do also our barrels, screws, all the core parts is here designed and manufactured at K2022. So we go on further. You may have seen that the die has also automatic system placed on. We can adjust the film thickness manual, and then we do have a cartridge heater in between the adjustment, and then the heating system, the cartridge takes over by loading that system with 50%. That means it's in the center, and by getting more heat on, we closing the lip, and taking the heat away, we open the lip. That system is then related to the thickness gauge. They are in closed loop, and the moment the operator has already reached manually a good tolerance of the film, he's going to get to the automatic mode. We might see here or not might, you see here the screen of the thickness gauge. At the moment we're running 560 micron with 3 micron intolerances. You can see here on the graph of the heating bolts. We are able here to run from 150 micron thickness up to 1.5 millimeter. Okay, if we go further on, it's a little tricky here, but you can see here our HMI. It's a Siemens-based HMI, and the main thing is that the program, all that was here done is in-house program. That means we have the total power of that system. It's not the need to phone someone and say we need your help, things like that. Everything is stored here, all the data from feeding to dosing, from the infrared clean system, all the data also from the winder, everything is stored here. You can create a recipe. But the main thing I would like to emphasize is that in night shifts, for example, there occurs mostly problems, and you want to say what was happening there. So you go into the system, you say 2 o'clock in the night. I choose from all the data we're going to log. We choose 8 data, and we're going to get that data on graphs. Every graph is colored and precisely in scale. So then you can see, okay, for example, you have chosen the pressure drop or the pressure gauge from the melt pump. You have seen first the pressure drop, you can see this, and then you can come to the conclusion the happening in the night was due to this and this. That's something our R&D guys like a lot, to see what was the case while the machine was interrupted, what was the thing going on. Okay, so we go here further on, and then we come to the special point where we hand the material coming from the die arranged vertically into the horizontal arranged roll stack, what we think is the best way, because it's half a way to cast, I would say. With having the automatic system running, we have already a very precise film, and the adjustment of the roll is arranged by hydraulic cylinders. In the hydraulic cylinder is a linear encoder, so we know where the hydraulic cylinder is, and with it we know where the roll is. That is the mode to run on precise gap. But here we run another mode. We give the hydraulic cylinder only a small amount of pressure. That means we're creating very little force in the gap. The die is arranged to get as close as possible into the gap. So what we call it the kiss with the material. That means we're giving the super finished surface of the two rolls only by touching the material very gently and not to creating a huge roller bank. What's creating a lot of stress in the material, a lot of force, and with the force you get bending of the rolls, you increase tolerances. These rolls are the linear contact rolls is arranged as a so-called contra-bending roll. That means the center roll is going to bend in one direction and the line contact roll is going to smoothen in that curve. These rolls are also in a special design, so we can reduce the wall thickness down to 60 millimeter. They are hardened, and with having only 16 millimeter of steel between the water cooling and the material, best would be to have only water. Then we are able to cool the material very quick and very perfect. So we go on here. We have the third roll in an inclined position. That gives more wrapping around the center roll, means more cooling. And we have arranged an idler roll underneath the third roll, so that gives more wrapping around the third roll. So in total we are able to cool the material very quick down. So we want to have the material in amorphous structure, so have the PET as clear as possible. So we go further on. Here you see the huge box. We need a lot of cooling water. We have only one heat exchanger, and by the pumps, every roll has its own pump. We are able to adjust the amount of energy we've taken out of the rolls with that only one heat exchanger. On top here you see the roller conveyor, and then we do have the thickness gauge. It's a contact-free thickness gauge, and it's also in the closed loop with the automatic system placed on the die. Okay, so we go further on. Here we do have the edge trim. That means we want to get rid of the not so nice edges. It's a rotary knife system. We can adjust the width from outside. We're going with the edge trim directly to the side in a grinder. And normally this material is going to be sent back to the process. Here we're going to get it into big bags, store it next to the line. That's due to the fact that's a lap line here. It's not a production line actually. So we go further on. We have here the takeoff unit. But it's actually not only the takeoff unit, it's also a system to do application of silicon or water-based silicon primer, I would say. In some cases, customers want to have the anti-block batch in the A extruder, and in some cases, customers want to apply silicon. Here, it's possible to do it on the top side or on the bottom side, or on both sides. And there is also a drying tunnel in to get the water then dried, and only the silicon parts will be placed on the film. And here, from here on, we can go to the accumulator of the winder. We're running here up to 90 meters per minute speed. That means we need a huge accumulator to give the operator time after crosscut to change from the ready reel towards the new reel. So this is capable of 90 meters, means 1 minute time for the operator to change the winder or the winding position. And okay, here we do have another rotary knife in the center, possible to place there. So like I said, we are able to run 1200 millimeter net, but we are also able to run 2 times 600 millimeters. With the deckling, we can go down to 750, one net, one web, but mostly customers want to use the full width for sure. Okay, we have here the winder. There's the takeoff unit in cooperation with the accumulator. It stops the system, the film, and we have automatic crosscut. Okay, the material, the film has then to be placed on the new position you can see here manually, and then you go out of the safety area and the winder is going to start. Also here, very important, the program for the winder is also done by us. The operator is going to see any alarm in real information that gives him time to decide what to do, because mostly operators are working here in that area, for example. So that's the end of the line we're going to show today, for example. But I would like also to give some information about our lab extruders. We have always these extruder here. That is a K60, means 60 millimeter screw diameter. Again, we have different barrels. We have 33D with groove feed section barrier screws. We have 33D. We have 36D with internal spirals up to the total barrel, for example. The speed of that extruder is 450 revolutions per minute. So we can get also into that high-speed technology a little bit. So you are more than invited to come to our place here with your material doing tests. We have a die in front. You can see the material curtain. You can see if everything is homogeneous, things like that. And last but not least, there is a small little extruder, for example, only a 25 millimeter. Capable for maybe 20 kilos, something like that, but you see everything is out of stainless steel. That is an extruder for medical application, for example. But also you are more than welcomed to come to our place to do tests. Okay, summarize, I would like to say, okay, the line is capable of the 1,000 kilos per hour, capable of running PET, PP, polystyrene. We're talking about 1,500 micron or 1.5 millimeter in thickness, up or down to 150 micron. The width is 1,200 net or 2 times 600. And that's it. Oh, the price, that's you ask our sales guys, and you will get a good quote from us. And I would say with the team here from St. Augustin, we want to say bye-bye to Düsseldorf. Regards to all, have a nice time in Düsseldorf, and stay safe. Bye-bye.